do a quick recap. It will probably take 2 minutes or so, then we'll just continue. I think Hari sir has given the video for this. Even I had made one video, but no, his has been shared. I'll just do it quickly here, and then we'll start with the second experiment. Okay, who's opening in space claim? Those of you who are using 19 above should not open in space claim. We'll use in geometry module only. What we'll do, close this. Okay, and right click, new design modular. Once you open it, go to create points, coordinates. This is your coordinates, Naka. Then generate front view. I'll just go faster because Harish sir has already done this. I mean, in this video. Okay. Lines from points. You guys zoom into this extreme. You can start from here. I'm holding my left button to get all the points. Make sure to touch all the points. If you miss anything in the center, it will not generate properly. So here, whatever. Okay. Take the zoom option again. Points. Okay. 131 points. Generate. That's been generated. Hope I haven't missed anywhere. Now go to concept. Create surface from edge. Again do the same thing. Zoom in on here. And then create a edge. And then join all of this. Don't leave your left selection. Holding left and then expand this and then usually select all of this. The coordinates is not specified in any scale. Therefore, whatever scale you keep the module in, it will load for that scale. So if you keep it in meters, it will load for meter. If you keep it in millimeter, it will load for millimeter. Since you want it in millimeter, you keep it in millimeter scale. Just if you're not sure, just take one circle here. Okay. Zoom in and then check if everything is connected. One point I've missed. I think it will come as an error. It went. So what you do is come for this end first. Okay. Select edge, hold control. For this, hold control because it will not continuously draw. Therefore, hold control. Because if you left go off the left button without holding control, it will start from the beginning. So hold control. All of it was selected, but confirm by going there. I think all points are connected. 131. Generate. Okay, so you have your surface. Now come to front view. Go to sketching. Click on rectangle. Just draw a rectangle like this so that you have all the axes covered. Okay. Then go to dimensioning. Horizontal distance. You need this distance. So vertical distance. Vertical distance. You need this distance. You need distance from this point to this point. And horizontal, you need this distance. You need distance from this point to this point. Okay. So H3, that is 4, and this is 1, and this is 3, and this is 1.5. So actually your rectangle should be 4 cross 3. So 4 cross 3, and this you keep the distance 1, and then generate. Okay. Now we have to create surface for the boundary. The surface from sketch. This is your sketch. Here this apply, generate. Now that is done. You need to remove this surface inside of this surface. So what you do? Create Boolean operation. It is not unite. Unite is to add and to subtract. Subtract target body is this. Apply. And tool body is this. Okay. Apply. And then generate. You have the cutout. Okay. Once you're done, you will have to name. You'll have to create name selection. So name selection. Use edge. This edge. Let us call it inlet. Generate. Yeah. Not attribute. And selection. Edge selection. This is for outlet. Okay. Head selection. Outlet. Apply. Generate. Name selection. Window. Wall. Okay. Normally, let me see if I can just check for the wall here and apply. Not able to apply. So you'll have to select it. Click on edge selection. And then Same procedure, hold control and try to. Or else, wait, let me see if I could use control A option. I'm not able to use control A. I don't know, sometimes it works and sometimes it does not. I don't know what is going on with this. Okay, this is your first wall. The remaining is here. Hold control. Let go of the control. Take the zoom option. Zoom in here. Click on it. Hold control and then select the rest. Okay. Click on apply. I think I missed one somewhere. Okay, generate. That is your wall. Now I can close this. Come to your mesh. Double click on it. Come to your front view. And in mesh. It was okay. Sizing. You take proximity and curvature. And then minimum size. And I can play around with this and then understand it. In my previous video, I've explained, what all different options, how they work out. Okay, you can go for adaptive, relevant center, find, element size. It's okay. Now first, update it. Just getting done. There's the mesh you got. So we can further refine it. Go to refinement, select the face, apply, update it. Okay, this is all you've got. This was within adaptive mesh. Okay, with that done, you can close, come to your setup, and here is your second experiment which begins. So come to setup, double precision. Okay, that means it will properly check for the results. Okay, this is ready. Now scale, keep it in mm, close. You can check it is done. You can report quality. So report quality, maximum aspect ratio. Still checking. Okay, here. Okay, it should be between 0 and 1. So 1 reports very good quality. So it should approach 1 and not 0. Okay, so here it is giving 6.0.6. So which is okay. Now we are doing it in a pressure-based model, density-based model you take for compressibility. So let's take pressure-based model, absolute, and fine. Okay, what all we need. Now go to models, and we are not turning off energy. And viscous is laminar, okay. And materials will be using air, okay. By default, everything is there, so I can close it. And then boundary condition, come to inlet, absolute velocity is 150 meter per second. Okay, gauge pressure, it won't change it, 0. Okay, and outlet, uh, again absolute, 0 gauge pressure. Okay, and wall, make sure it is stationary wall, no slip. Okay, and then come to method. I can go for simple d square second order of wind controls. Okay, monitors check for residual. It should be 0.01 and for all of this. Okay, and here iteration to plot 1000. Okay, now go to initialization. Take hybrid initialization and initialize. Okay, and then for calculation activities, run calculation. Number of iteration is 1000, and then start calculating. So it has to converge. Once it has converged, then it will stop. Actually, the graph should come down. If it is not coming down, the convergence criteria is not being met. Let me run for another 1000 because the convergence criteria is not met. So we'll see. We'll just run for another 1000 and then we'll go for results. Okay, close it. Now come to result. Okay, this is what you'll have. You can just click on all of this, but you only need symmetry for now. That is the result point. Okay, what will take? You have to click on contours. Contour 1 here, What contour do we need? We need on symmetry. We need pressure contour and apply. So this is your, it is a little different. I'll just increase this number of contours to 50. This is the number of color variation. Yeah, so you can get more detail. Okay, so that will increase. I think it is a bit off. It will perfectly come as a dome here. I think because of the point I missed somewhere, it was not coming. Okay, find it. Let's see. What we find. I'm not able to make out the lines. So I'll take 250. Yeah. Okay. So this is how you would write in your uh, what is that? Pressure difference over an airfoil. Correct. So you've got your pressure, and you've also got your velocity. So you can observe how the velocity and pressure is varying. I'm not completely satisfied with the pressure variation because I think I missed a point somewhere. So you can see here there is a little deviation. So I think because of I missed a point, it is not perfect, but it will come perfect. You guys will try and get it out. So and then you can take your results from here. See, I think there is a see, this option. If you use JPEG, you can save it in wherever you want. So let's take it as velocity dot png. Okay, and one thing I want to specify is that this the versatility of using ANSYS will only come with experience. So the more you work around with it, the better it will come. See, this is your JPG wherever it has been saved. We'll go to the drive first. So here, okay, and then we'll see our pressure result. Apply. You can also save this, but this is more prominent somewhere, but the procedure is correct. Okay, so you guys try and get the actual answer. This is your second experiment, which is beginning from the setup. And please know the boundary conditions. The boundary conditions are laminar flow with an inlet velocity of 150 meter per second. Okay.